My last topic is about regression analysis in chapter 15. Regression analysis is a set of statistical process for estimating the relationship between a dependent variables, often called the outcome, and one or more independent variable, often called predictors or features. The most common form of regression analysis is linear regression, in which one finds the line or a more complex linear combination that most closely fits the data according to a specific mathematical criterion. It is also a reliable method of identifying which variables have impact on a topic of interest. The process of performing a regression allows you to confidently determine which factors matter most, which factors can be ignored, and how these factors influence each other. For example, the graph below. Formulating a regression analysis helps you predict the effects of the independent variable on the dependent one. As we can see the graph, that age and height can be described using a linear regression model. Since a person's height increases as age increases, they have a linear relationship. Under the regression analysis, we have number one, standardized regression coefficients. Standardized coefficients allow researchers to compare the relative magnitude of the effects of different explanatory variables in the path model by adjusting the standard deviations such that all the variables, despite different units of measurement, have equal standard deviations. And number two, regression with dummy variables. A dummy variables, also known as indicator variable or just dummy, is one that takes the values 0 to 1 to indicate the absence or presence of some categorical effect that may be expected to shift the outcome. Dummy variables allow us to use nominal or ordinal variables as independent variable to explain, understand, or predict the dependent variable. As you can see, the sample, we have a gender of male and female, and it is being dummy or changed by number sign. Say we can have the categorical variable gender there in our regression equation, and the numbers represent the dummy. This is 0 for male and 1 for female. Number 3, multicollinearity. Multicollinearity is a statistical concept where several independent variables in a model are correlated. Two variables are considered perfectly collinear if their correlations coefficients is 1 over minus 1.0, multicollinearity among independent variables will result in less reliable statistical inferences. It is often encountered statistical phenomenon in which two or more independent variables in a multiple regression model are highly correlated. The main causes of multicollinearity are A. Inaccurate use of different types of variables. B. Poor selections of questions or null hypothesis. Letter C. The selection of a dependent variable. And D. Variable repetition in a linear regression model. Number 4. Testing moderation using regression analysis. Interaction effect. Moderation effects are often referred to as statistical interactions in the social science literature. The terms are interchangeable and refer to the same phenomenon. A mediator variable, M, is a third variable that explains how or why two other variables, for example x and y, are related. And that's the end of my report about quantitative data analysis hypothesis testing. Thank you.